Welcome back. This is 7.5 Defining Systems. In your textbook, this is section 6.5 with a different title, Do Action and Reaction Forces Cancel? It's the same exact section though. So the big idea here is that action and reaction forces don't cancel each other when either of the forces is external to the system being considered. So let me give you an example. If I push someone, I could get them to fall over. I could accelerate them somehow away from me. But if my right hand pushes my left hand, I don't go anywhere. Like I could push my left hand with my right hand all day and I don't go to the left or to the right. I just stay still because my left hand and my right hand are inside of me. So I can't accelerate me with my right hand or my left hand. But I could accelerate someone else with my hand because my force is exerting on them, and that is external to me. So the system is something that you would look at, whatever you're considering, that could be moved or not moved. So if I consider, say, my left hand and my right hand as different systems, I could play push the hand over, and I could force my left hand over or force my right hand over. So as long as I'm thinking of my arms as different systems, I could accelerate one or the other. But if I'm thinking of my whole body, I can't accelerate my whole body with my left hand pushing against my right hand. Nothing would happen. So the big question is, since action and reactions are equal and opposite, why don't they cancel out? All right, so to answer the question, we have to think of systems. We have to be able to define what is acting on what. All right, so the silly picture of an orange. If an orange is being acted on by a force outside of the orange cart, the orange in the cart, then you could move the orange inside the cart. Okay, if there's a force outside of that orange and cart, you could move that orange and cart. Okay, so the dotted line is enclosing the system, and then the red arrow going outside the line is showing you have a force external to that system, and that external force, like it's putting a force on something, and maybe that something will put a force back on it. We'll see. So if Mr. Apple pulls on Miss Orange, okay, then that apple is external to the system we were looking at, and that external force can cause the orange and the cart to accelerate. But if you're inside the cart, you simply pushing on the cart is not making anything move. You can't move yourself inside the cart by shoving on the steering wheel or shoving on the gas pedals with your feet. You can't make it go. You can push the cart, like if you got out of the car and pushed on the car, if it was just a play car, you could make it move. But you cannot be inside the car and be shoving on the car from the inside and make you and the car move, because you have to consider that the force has to be external to the system that's moving. So if the force is provided by the apple, which doesn't change the analysis. The apple is outside the system of the orange, and the orange simultaneously exerts on the force of an apple. Okay. Now look at this last sentence. I think this is the best part of the whole section. You can't cancel a force on the orange with a force on the apple. The only way you can cancel two forces if they act on the same object. So look at an example. If you kick a football, that foot is acting as a force on the football, and you're accelerating the football. As long as it's in contact with your foot, it's accelerating. If two people are shoving on the same football from two different directions at the same force, the football isn't going anywhere. So if you were to have a box, okay, you have a box, and I put a force on the box and a force going in both directions, both of those will cancel. So if you have two forces acting on the same object, equal and opposite, they cancel each other. But if you have one object putting a force on something and the other object putting a force back, whichever one is the smaller mass is going to accelerate backwards. Okay, so if two forces that are identical are on the same object, no acceleration happens. But if two objects are putting forces on each other, so it's not on the same box or not on the same football, but on each other, whichever one is of the smaller mass is going to accelerate backwards. That's the idea of systems. You have to know what's being accelerated and where the force is coming from. Let's see if you understand. Suppose a friend who hears about Newton's third law says you can't move a football by kicking it because the reaction force by the kicked ball would be equal and opposite to your kicking force. The net force would be 0, so no matter how hard you kick, the ball won't move. What do you say to your friend? Whatever you say to your friend will show you whether you understand this or not. No matter how hard you kick that football, the football's not going to move because it's going to exert the same force on you and you'll cancel each other out. Does not make sense, does it? Why don't action-reaction forces cancel each other out? Because they're not on the same object. They're on different objects. And as long as you've got forces acting on different objects, whichever object is smaller mass will accelerate more than the other. If they're equal masses and equal forces, then that would be like a arm wrestling match where you're at a tie. Okay, neither one is winning. But if you have one that's stronger than the other, one that is more massive or less massive than the other, then you're going to have motion. The smaller mass will be accelerated backwards.